guys, welcome back to my channel Crackboard 1920. It's Verma. Today we are going to discuss about some very important questions of differentiation. So let's start. First question is, if x under root 1 plus y under root 1 plus x is 0, then prove that dy by dx equals to minus 1 upon 1 plus x whole square. First of all, we arrange y in terms of x like this, which is in the form of a fraction. How? Firstly, we transfer this term in RHS, then squaring both sides. X square 1 plus y is equals to y square 1 plus x. Okay. Then transfer all the terms in LHS. We will get x square minus y square. This becomes x plus y into x minus y. From these two equations, we take xy as common factor. We have x minus y. Now, from this and this, also we take x minus y as a common factor. From here we have x plus y. From this term we have xy. So now we have product of two terms equals to 0. Either first is 0 or second is 0. But when we take first term is equals to 0, we will get y equal to x. So dy by dx equals to 1. But we have to show that dy by dx is minus 1 upon 1 plus x square. So we take this factor equals to 0. Now x plus, again y common from these two terms, we have 1 plus x. Now we calculate y. Transfer this x in RHS and this term in denominator. Now we have y in the form of fraction. Now we apply quotient rule. By quotient rule, denominator square here, denominator as it is, d by dx of x, which is 1, minus x as it is, d by dx of this term 0 plus 1. So after simplification we have minus 1 upon 1 plus x whole square. Okay. Now next one is fx equals to under root x square plus 1, gx is x plus 1 upon x square plus 1, and hx is 2x minus 3. There are three functions f, g and h. We have to find f dash, h dash, g dash x. So how? First of all, we calculate f dash x, d by dx of this function x square plus 1 whole power half. By the formula for d by dx of x to the power n, that is n x n minus 1. So in place of n we have half, and by chain rule, firstly we differentiate this 1 upon 2 under root x square plus 1. Okay, half minus 1, that is minus half. So in denominator we have under root. Now d by dx of this factor, that is 2x. Now 2 cancel out. So we have f dash x is x upon under root x square plus 1. Now g dash x, d by dx of x plus 1 upon x square plus 1. By quotient rule again, x square plus 1 whole square, this denominator as it is, d by dx of numerator, which is 1, minus numerator as it is, and d by dx of denominator, this is 2x. After simplification we have 1 minus 2x minus x square over x square plus 1 whole square. This is the value of g dash x. Now when we find h dash x, d by dx of 2x minus 3. So this term becomes 2 and this is a constant. So h dash x is not depend on x. This is a constant. When we replace this x by g dash x, again we have constant. So this complete factor becomes 2. Right? Now f dash 2. We substitute 2 in place of x in f dash x, and this becomes 2 upon under root 5. Right? Now next one is differentiate tan inverse under root 1 minus x square upon x with respect to cos inverse 2x root 1 minus x square. When we have to find derivative of first function with respect to another function, firstly we substitute first function equals to u and second function, that is v. Now we have to find du by dv. First of all, we differentiate u with respect to x, then v with respect to x, and then we divide. How? u equals to tan inverse root 1 minus x square upon x. Firstly, we simplify this inverse function. Let x equals to cos theta or theta is equals to cos inverse x. Then u equals to tan inverse under root 1 minus cos square theta upon cos theta. And 1 minus cos square theta is sin square theta. Under root of that is sin theta. Sin upon cos is tan. Tan inverse cancel out. So we have only theta. And what is theta? Theta is cos inverse x. Then we differentiate with respect to x. We have du by dx is minus 1 upon under root 1 minus x square. This is formula for cos inverse x, right? Now let v equals to cos inverse 2x root 1 minus x square. Also this is an inverse function. First of all we simplify this. Substitute x equals to sin theta. 2 sin theta under root 1 minus sin square theta. This becomes cos square, under root of that is cos. And 2 sin theta cos theta is sin 2 theta. Now this sin convert into cos with the help of pi by 2 minus theta. So cos pi by 2 minus 2 theta. Cos inverse and cos are cancel out. Now we have pi by 2 minus 2 and what is theta? Theta is sin inverse x. Now we differentiate with respect to x. We have dv by dx equals to minus 2 upon root 1 minus x square. Now du over dv equals to du by dx upon dv by dx. Substitute the value of du by dx and dv by dx. Now answer is 1 by 2. Now next is, if y equals to sin inverse x under root 1 minus x minus root x under root 1 minus x square, then find dy by dx. First of all we simplify this. X equals to sin alpha implies alpha is equals to sin inverse x. Then what is under root 1 minus x square? This becomes 1 minus sin square alpha equals to cos square and under root of that is cos alpha. Okay. Next one is, let root x equals to sin beta. Again beta equals to sin inverse root x. Then under root 1 minus x is equals to 1 minus root x square, that is sin square beta. And 1 minus sin square beta is cos square beta. Under root of that is cos beta. Now this value becomes sin inverse. This is sin alpha. This value is cos beta. This value is sin beta and this value is cos beta. Okay. Sin A cos B minus cos A sin B. This is sin A minus B. So formula is sin alpha minus beta. Sin inverse cancel out. We have only alpha minus beta. Sin inverse x minus sin inverse root x. Now we differentiate with respect to x. So dy by dx is, formula for sin inverse x is 1 upon under root 1 minus x square, and formula for sin inverse root x by chain rule. First 1 upon 1 minus root x square, that is simply x in under root. Now dy by dx of root x, which is 1 upon 2 root x. So answer is this. Y
Next
equals to cos inverse 3x plus 4 under root 1 minus x square whole upon 5. Find dy by dx. Again this is an inverse function. So first of all we simplify this. We want to try that this becomes, complete terms becomes a formula for cos a plus b either or cos a minus b. So we substitute 3 by 5 cos alpha and x cos beta. Now sin alpha is under root 1 minus 3 by 5 whole square. After simplification we have 4 by 5. This value is 4 by 5. When we substitute cos alpha is 3 by 5, we have sin alpha is 4 by 5. Again if we substitute this x is cos beta, then under root 1 minus x square is 1 minus cos square beta. This is sin square beta. Under root is sin beta. Now cos alpha cos beta plus sin alpha sin beta. This is formula for cos alpha minus beta. Cos inverse cancel out. We have only alpha minus beta. What is alpha? Alpha is cos inverse 3 by 5 and what is beta? This is cos inverse x. Now we differentiate this. Dy by dx is derivative of constant. This is 0 minus, formula for this, minus 1 upon under root 1 minus x square. Minus minus becomes plus. Now next one is, if y equals to log x plus under root x square minus 1, prove that x square plus 1 into d2y by dx2 plus x dy by dx equals to 0. Firstly, we differentiate this by chain rule. First, we apply the formula for log. d by dx of log x is 1 upon x. Therefore, first term is 1 upon x plus under root x square minus 1. Then d by dx of this function. d by dx of x is 1. d by dx of this term is 1 upon 2 under root this same term, and d by dx of x square minus 1 is 2x. 2 cancel out. When we take LCM, we will get under root x square minus 1 plus x whole upon under root x square minus 1. Now this complete factor cancel out. Only we have 1 upon under root x square minus 1. When we prove these type of equation in second derivative type, then here, from here, this denominator transfer in LHS. Then we differentiate by product rule. First we differentiate this term, we will get second derivative. Then in second term we differentiate this term. Derivative of this is again 1 upon 2 root x square minus 1 into d by dx of x square minus 1, that is 2x. 2 cancel out, and when we take LCM, under root x square minus 1 multiply by this factor, we will have x square minus 1 second derivative plus x dy by dx, and after taking LCM, this term transfer in RHS, multiply by 0, get 0. So this is the required equation which we have to prove. So these are some very important questions. So आज इस वीडियो में इतना ही. वीडियो पसंद आए तो like my video, share it with your friends, and don't forget to subscribe my channel. One more thing, please do comment how is the video. Thank you.